Hi everybody. Well, today on the bench we have another save attempt. It is an HP 8660C synthesized signal generator. We also have an 86603 RF generator, which I have purchased separately. It's meant to be used as a second plugin, which is the modulation section. The main frame, it's used as the main source for the RF section, which in my knowledge there are 3 RF sections. One is from 0.1 to 110 megahertz. The second one, not sure if start from 1 megahertz to 1.3 gigahertz, and the third one, the one I have here, is from 1 to 2.6 gigahertz. Now, the signal generator has been sold as is, unknown condition. That we know what that means. Unfortunately, also this one has been damaged during the shipping. Less damage than the frequency counter, but again, look at the handle. These are very heavy instruments. If they are not well packed, they get damaged. Also, there are rare foods that also are bent. Now, about the modulation section, there are several modulations. I think I know at least 4. One is the auxiliary modulation section, which means to modulate by an external source with AM modulation. Then we have phase modulator and AM and FM modulator and phase and FM modulator. Now, all those are quite pricey, and I'm looking for a good deal as ever, as the instrument has been not really cheap, but should be complete, hopefully, and yeah, it's worth to save to attempt to save it, as it's quite powerful instrument, and it will also cover the range that I was hoping to cover with the other sweep generator that I repaired a few months ago, which was the 8350B, which I still need to find a good price plugin. They are really priced. So the plan is to remove the RF section, open the lids and see how it's inside, and start as ever the reborn attempt of this beauty. This is the rear panel. As you can see, those fits are bent, but hopefully these are fixable. We can see here we have a reference output. Maybe that that means that we have an internal overnight crystal oscillator. I think this fan is meant to be swivelable, so can rotate in some direction. And as you can see, somebody has used a screwdriver directly onto the screws without the removal of the top lid. So let's go to remove the top lid. Okay, let's see what we got. As ever, very difficult to remove because of the damages that occurs. And again, with a small screwdriver, I've been able to lift it. Oh, that's a bit sad. I'm seeing a bit of oxidation signs. Not really bad, but yeah, not sure how deep can it be. Now here we have what seems to be the power supply. Maybe this is a regulator board, and I have just lifted straight away. Yeah, E5 regulator, and it seems there is a missing component yet over here. Let me grab something. It seems that we have a missing component here, maybe a capacitor. I'm seeing plus sign. Yeah, for sure here somebody has been in before, as ever with these aged instruments. Down there we have some strange sort of connector. I don't think they are, maybe a test point, not sure. Nothing, I don't know nothing about those. By the way, so let's try to prepare a plan here. I think, as ever, we need to be sure that the power supply is working fine and does not create any additional damages. So I think I need to remove everything but the power supply. So yeah, they will see. Oh, by the way, I'm just noting that maybe this is a sweepable section. Let me grab a screwdriver and see. It seems that removing the look at this fast loosening. Oh my goodness, what a beauty. I think there are birds under there, so I need to remove also the lower lid. Yeah, bottom lid. Whoa, what a mess. Look at here, oxidation signs, and I think this instrument has seen water in the past. That is pretty bad, pretty bad. Okay, so I think yeah, we have no choices. We need to remove everything from here. Be sure that is 100% clean. This is almost loose and laying on one side. I think we have another nightmare in front of us. But yeah, this is my mission. Try to save these beauties. I sprayed all the screws with WD-40, so I will soak them with this for a while, and meanwhile we're removing the other side panels. I want to see if I can get them loose a bit easier. Well, I've removed all the boards, and I've noted that we have the board code on each slot, and the board position was matching what written on here. And this is the controller head removal. It has been, seems to remove some screws back there, and it seems that we are not able to remove, as everything here is bent out. So I think I need to remove also the other screws and remove all the boards. All the boards are out, and this is the control head out. I've just noted that one knob here is broken, and yeah, that is unfortunate. Going ahead with the dismantle, I've noted that here we have other birds, which unfortunately somebody before has broken all the colored handle for the lifting, but this board seems already out, and it is out. Yeah, that might be because of shipment. It was pretty tough, pretty crude. The shipment has caused several damage. So let's get all them out. But I think this cage also can be removed. This instrument must be, yeah, look at that, it's moving. This instrument must be completely dismantled, as the oxidation extent it's worse than I was imagining at the beginning. This instrument is packed of birds everywhere. Also, the rear swiveling fan unit can be removed as an entire section. We have, I think, a pass transistor over here. Scaring discovery. Here we have what seems clipped wires. Wires are pretty short, but it seems a thermistor over here. So might be that we miss a thermistor also over there. And must be checked through the manual, through the schematic. Well, looking at the schematic, we only have one thermistor, so that might be the 0.1 microfarad capacitor reefer, maybe, that has exploded. Well, unfortunately, I've just discovered what those two are. They are socket, and it's meant to live up on those two relays, which are used to switch from standby to on position, and they are driven by the on-off switch onto the front panel. Actually, it's standby on switch. So I must put this in standby, and I need to figure out if I can find the drop-in replacement, or I will need to make some modification. Well, it seems that I may have found a replacement for the two relays, hopefully and possibly. So I decided to go ahead and continue the dismantle of the instrument, as it is in really bad shape. And surprise, we have some burnishing signs over there, and there are traces that are burned, and I think also splitted in half. It's quite deep over there. I think I would avoid to remove the power supply board, the rectifier board here, as it is crowded of wires soldered directly onto the PCB. So let's see if I can, in a way or another, find a way to expose those sections and attempt to repair. But at this point, I'm expecting a nightmare. Well, it seems that I found a solution for this A20 rectifier board. So I will remove all the big capacitors. I'm also attempting to reform, but this is the taller one which has been replaced, and somebody has cut a hole as It's longer than the original one. So I think the original should be like this. With the exposed PCB, we can see now the extent of damage, which is quite a lot. This trace is completely broken. This seems to be just roasted. I will check with the meter. And this seems to be a ground path. And this, I believe, it's coming from the transformer, which has a connector over there. So I think before to go ahead, we need to inspect the secondary, that there is no problem with that. Here you have 3 bridge rectifiers that must be inspected. So still a lot of variables which should be taken care. I've removed the bridge rectifiers and they are fine. However, there is this oxidation sign which is also onto the PCB, but I don't believe that is the cause of the burning, and that are a crappy work onto the capacitors. And yeah, there is also over here the same, maybe some liquid has spilled in. I have removed these 2 capacitors that were being tagged in just to replace the old one. These are 220 microfarad, and those are C4 and C5, and they should be 470 microfarad. All the ceramic fuses are fine, but actually if I look at where they are after the rectification. So if we have a problem with the capacitor, we have a short circuit, for example, we have a short directly onto the bridge rectifier, and that will overload the transformer. The main fuse here, I can't find it right now. It's over here, but it is as requested from here, 2 amps in 220 volt, which is more than 400 watts, and that for sure will make the PCB blown like that. So the plan is I have just glued with super glue the original trace. I will make a small jumper here. It seems fine to me, and this I'm pretty sure has been caused by capacitors. So I'm in the process of reforming the one that was replaced, which is longer. It's perfectly fine. I'm trying to reform the other ones, but for sure those must be replaced, as they are nasty and corroded. Oh, I've just made a magic discover. They've removed the release and they've simply jumped. So no standby and on action, just on. So I will remove all the solder blobs and hopefully I will be able to restore the original configuration. Some maintenance with fresh thermal paste. Well, the board is repaired and I have replaced the 2 wrong capacitors, the wrong fuse. I have reinstalled and cleaned all the bridge rectifiers. I check all the bridge rectifiers, all the fuses, everything is fine here. I also have already checked the power transformer, seems fine in all its output and input. Here is the board bay, which was in need of cleaning, and seems fine to me. Wiring harness, it's almost clean on the top side here. Need to finish the lower side, and then we'll be ready to reinstall the power transformer and back panel. And reasonably, we should have at least the unregulated DC voltages. So the rectifier section is in place, as well as the main transformer, the rear panel. I will not go beyond that in a reassembly process. I will leave open here. I just want to make a very basic test onto the capacitors, on all the DC unregulated voltages, as basically this board, it is represented in this dark area here, and we can go and apply power for the very first time and check if everything here is working and it's giving the appropriate DC rectified. We have a bleeding resistors on each arm, so on each rail. So I think it will be okay. The only one thing that I want to do is to remove F5, which is right the upper one here, because I'm not sure that this will be functioning, so I don't want to inject any wrong voltage onto the oven. As you can see here, is going to the oven. So quite mechanical tasks so far, so no electronic checks. This will be the very first. Oh, by the way, this I forgot to mention that this reference oscillator here is made by Bulova. All right, I have my dim bulb in line, which is right here, and I have my variac enabled, cable connected, and let's see if we have some live sign. We have 43 millivolt here, and okay, so seems fine so far. Oh, I just forgot to remove F5, which is the ceramic. Okay, let's try to rise up some voltage. I will not worry about the speed, as I have already reformed it, and indeed we are already seeing some voltages. 1 volt here. This should be negative, okay. And over here we got 4 volt. Let's see over here. We are in the millivolt. So it seems that we have some live signs so far. So let's crank it up. Dim bulb, it's 40 watts, and it's completely off. No current sign. And we have at -18, and we are at 100 AC volt. And remember, this instrument is set for 240 volt. I will leave at this voltage for a moment. Well, I'm raising the voltage as it is almost 10 minutes, and I have no bad indications so far, so it seems safe enough to rise to almost the line. On this -56 volts, it is meant to be the feed of the minus for the regulated voltages, so seems fine to me. A bit of over voltage, 35 volt here. It looks fine so far. So I think we are good enough, and we can go for connection directly to the line. I will make the capacitor discharge and see if we have some flash onto the dim bulb. It's almost 5 minutes that I'm waiting the capacitor to be discharged, and we are still seeing some voltages on them, especially on this 18,000 microfarad, which is I believe the 5 volt rail is dropping, but very slowly. So that means that our capacitors are good to go. But I want to try to go directly to the line and see at the dim bulb what is going on. So 3, 2, 1, and yes, we had a flash, and then everything went down. Let's see if we have still voltages over here. Seems fine so far. Well, at this point, unfortunately, I can't go ahead as I not received the replacement release, and that makes the project in standby. So I think I will finish this video right now, and in the next attempt will be the resurrection of the regulator birds, and I will apply some dummy load, some resistors, and see if we can be safe to install all the birds and make the instrument back in business. So I thank you very much for watching, and I'll be back soon.